Okay, folks, thanks for joining me tonight. I'm just checking all my levels here. Looks good. Hi. All right, so it's 5 of 7, and so I like to give myself at least 5 minutes just in case something happens. No, it hasn't. Great. So, to everyone who's joining me tonight, thank you so much. My name's David Gonsalves, and on Sunday nights, I come down to the workshop and work on radios, electronics, hobby projects, and I invite you all to look over my shoulder, have a chat, and enjoy a little light entertainment watching someone else work for the evening. So our subject today is the Lafayette Explor-Air Regen radio kit. There's a bit to that, but in essence, we're talking about looking at a vintage 60s radio receiver that covers both the AM broadcast band and it claims most of shortwave. Everything from the bottom all the way to the top and a little bit more. 30 to 32 megahertz. I think it's kind of hopeful, but that's what they say on the dial. So we'll start with that. So Lafayette was one of many companies in the 50s, 60s, and 70s looking to find a way to amuse technically minded adults and kids in their evenings. If they stayed up to scratch, they could buy one of these lovely kits, which for them is a pile of components, a manual to put it together, and over the course of an evening with a soldering iron and solder smoke wafting up into your face hour upon hour upon hour, that eventually you'd get something kind of neat out of it. So this, and by the way, if anyone wants to reach me, feel free to ping on chat, and I'll look down occasionally to my laptop and get to it. So let me show you what we have on the bench today. Here it is. This is the Explor-Air. It's right there. Something that sails the open waves, seas, explore. Should be a little plane, I think, over here, kind of zooming across the sky. There's a few more knobs than you usually see on a radio receiver. You'd get the volume knob, and this one does have a volume knob right there. And then you have tuning, although this one has 2 tuning knobs. The left one here, that's the main tuning, so that's where you mostly are able to explore across all the bands. So the entire AM radio band, that's this kind of marked off on this inner line here. Probably 560, 570 to 1600. And then if you wanted to listen to other bands, you rotate the band switch. So here it is. This is set up in the A band, which is the AM broadcast band. If you want to listen to other bands, you can click over, and then these outer dial indications count. This B band goes from, let's say, just less than 1700 to 5 megahertz. So low shortwave, and then you have mid shortwave on the C band, and then all the way up to the top of shortwave on the D band. This little receiver, and it's not big, by the way. This is a standard sheet of paper. That's how wide it is. It's definitely shorter, and it doesn't weigh very much. It's quite light, and when we turn around, you'll see that too. Lastly, we have a couple other weird controls. On the left, we have what's called antenna tuning. In other similar radios, that might be called antenna coupling. And over here, we have what's called a regeneration control. So This is a special shortwave receiver. I'm going to go to the top view. All right. All right. So looking from the top, we see that it has these vacuum tubes. Let me just pull one out. These slender, late 40s, early 50s, all the way to when they stopped making them, vacuum tubes. Just 3 in here. And let's go ahead and let you know that the vacuum tubes, they tend to be dedicated to 1 or 2 functions at most. The part that actually does the active radio receiving, that's this tube here. It's a 12AT7. That's a nomenclature. So if you want to go, oh, this tube went out, I need a 12AT7, that's the one you go to the, I don't know, drugstore. I have to admit, I'm not old enough to have experienced getting these repaired. They're always out of date when I started to play around with them. But that's the one that does the main receiver tuning and detector and all the fun stuff. One of these tubes is used to turn the AC, which comes in on the back, and it rectifies it, helping it as part of a circuit to turn it into DC, because really, ultimately, all these circuits run primarily DC currents, amplifying these high-frequency RF currents and voltages off the antenna. Finally, on the right side, we have the 50C5, which is used as part of the audio amplifier circuit. And we see that there's a speaker right here. Apologies, let me just take care of this. I'm going to focus. A little bit better? All right, very good. We'll stay there for a bit. Then we have an audio amplifier circuit, and that either goes to the speaker over here, or to the headphone jack that's back over here. And then finally we have some other components. There's what's called a variable capacitor. Kind of looks, and that looks nifty. There's these parallel metal plates. They're all held together and they're connected to this shaft. And as you rotate the shaft, they mesh in between. They don't contact, they just mesh in between these plates here and here. So that as you close it, they mesh closer and closer. And in fact, they're just right completely in between each other here, all the way through. This part's called a variable capacitor. As the 2 parts mesh closer and closer, an electrical property called a capacitance increases for every little bit you get them closer. And of course, if you have them like so, they're fully unmeshed, and there's a minimum amount of capacitance that this component is giving us. On the right side, we have very much the same, just a really small version of what we saw over here. And then we have an audio transformer, and that's used as part of the audio circuit. Okay. What's this all about? What's a regen radio? Why is it different from anything else? Why does it matter? Why was it built like this? So I'll start from the beginning, just after the beginning of radio. And I'm going to keep this nice and short for you folks, because there are plenty of great resources which we'll be talking about later tonight. You can take a look about radio in general, as well as this radio specifically. I'll be happy to show you a great website done by a fellow vintage radio enthusiast, all about this particular model. Anyway, let's start beginning at the beginning. So when radio was invented, and let me just focus for you folks. When radio was invented, the concept of how to receive is that the antenna is being is in contact with these radio waves, wherever they may be coming from distant ships out over the horizon, whether it hits a weather report from the Coast Guard, or is it from the kid down the street who figured out how to make his own ham radio? So you'd run some wire. That was your antenna. It was actually half of your antenna. So this bit's the part that got exposed to the sky. The other part, the thing you're somewhat working against, is the connection to ground. Now, I am glossing over by saying working against immensely. The subject of antennas is a big one. It's a fascinating one, at least in my opinion, but I am not going to go through that today. But suffice to say, the idea is you put up some very large piece of wire, which would get exposed to the incoming energy of the RF waves, and you could use this energy and receive signals by this connection and this circuit here. A really early circuit for receiving radio was something called the crystal radio. And it was called a crystal radio because there was a literal crystal of metal that had a very special function. So these radios were very simple. You'd have a connection, usually antenna and ground, to some coil. And that coil was also connected to something called a variable capacitor. And that this coil and variable capacitor worked together to tune this whole setup. It wasn't just tuning the coil and capacitor, but actually the whole system to be best receptive to those specific frequencies that you're interested in. And then the crystal comes into play after that. That crystal was essential for being able to, when you could say decode, or you could call it detect those signals. So if you got some sort of noise or click from your headphones, that meant that a radio wave at that frequency you tuned your coil capacitor to had come in. And if you heard nothing, well, nothing came in. And then next we go off to a pair of headphones. They literally looked like this, two telephone type receivers, these small black metal cans. And I think they literally call headphones cans, on posts with a little headband going over the top. I've worn one for a while just for the heck of it. I don't know how they did it. They're painful. They were not comfy. Maybe they wrapped it with cloth or something. I don't know. But generally, this is what a crystal radio would look like, and you could get signals. Down below is a schematic representation. So here's the antenna, here's the ground connection. This curly shape here, that's a coil, right, like that. And this symbol here, which is these parallel lines with an arrow through them, that's called a variable capacitor. Those would be connected what's termed in parallel, so like this and like so. This formed the tuned circuit, the thing that would help you select the specific the radio signals of a specific frequency you're looking for. These would then be put across a crystal diode. So crystal is that little bit of mineral here that's being used. And what it does is work together with this capacitor to form what's called the detector function. A radio signal that has some signal on it, say, AM radio station is broadcasting, let's say WBZ 1030, and there's this immense radio signal at 1030 on the dial. Well, that signal is just not, has nothing on it. It's a signal. It has what's called modulation. Modulation being that audio that is somehow mixed with the radio signal. This pair of components here, that little crystal mineral and this capacitor, act to extract, to detect the radio signal, that modulation that's on the radio signal. And then from there, you can do a number of things, but most radios, they could just detect and connect directly to a pair of headphones. So you can build one of these still today. You can run up a bit of wire. You can get all of these components. This crystal, which is galena, it's a lead-based mineral. you can still put all this together and get headphones off of eBay, and it'll work today. You can get AM radio stations, or you can even get shortwave radio stations. You could even build an FM radio receiver using this principle. And everything we're going to talk about through this part of the stream is based on fixing some of the problems in this basic setup. You easily see if you have too many signals all close together, well, I hope that my tuning circuit works well enough. And if the signals are not very powerful, all the energy, just to note, all the energy it takes to allow you to hear it, enough power for you to hear it, all completely comes from the antenna. There's no battery in this system. There's no amplifier. All that energy is all you get from the station. So it really only works great if you build it for very high power stations, including AM broadcasters like we have. So what can we do? Some of those problems I mentioned is that there can be a well, I guess first is that you need a strong signal, because every bit of power you get out of this thing has to be in the radio signal that you got. So what if I wanted to hear something a little weaker or far away? You know, tough luck. Put up a better, larger antenna, put it up higher, put it up bigger. I mean, at some point, maybe you just think about just calling them instead. In addition, there's these properties called losses in the coil. There is a whole subject I'd love to cover another time, maybe as a standalone video rather than a stream, talking about coil losses. But just suffice to say, there's a property in just about any coil you produce, some are better than others, that makes its tuning kind of broad. What does that mean? Say I'm listening to a radio station at 1030 WBZ for us here in New England, right? And there's another station, it's at 1050, right? So they're only separated by 20 kilohertz. This tuning broadly, let's say that the coil can allow us to select 50 kilohertz of the RF bandwidth that's out there, right? Well, this is this difference we're trying to have to keep these separate. It's smaller than this number. So if you use a radio with a coil that's so lossy that it has this width, which is not unreasonable to be honest, you're going to pick up these two radio stations at the same time. And if you build a crystal radio, and you can get those as kits on eBay, there's a number of science kits that you can build this. If you put that together, that's a really common thing that happens. You'll find that you really can't get it to select a station. You just have to get lucky that those two stations are many frequencies apart. Many tens of kilohertz apart. And then lastly, because you're trying to derive all of your audio energy from radio, you really can't drive a speaker. Well, obviously you have a speaker, so we can't have a crystal radio here. So how can we fix this? About the time people were just getting this all working, I should say, that crystal radios were they were common where they were needed, but there were developments in inventing something called the vacuum tube. When that came around, they thought, well, how about we put an amplifier so that we can take those RF signals and boost them before we detect them and turn them into audio. So in this schematic, we have a little quick representation. Here's the antenna and ground, and then we have some sort of coupler circuit, some coil or transformer or something like that might be here, just to help best adapt the signals from here to the next stage, which is a tuned RF amplifier. That is, this amplifier doesn't just blankly bring everything across, because we're trying to select one signal, not the whole swath of signals that you possibly do. So the tuned RF amplifier has in it, at least at the time, a active element, a vacuum tube, and some tuning control. So you could set the frequency at which it would at best amplify, and that would tend to be the signal that you would detect and then get the audio signal out of. And then finally you have a detector, which again could be as simple as that diode and capacitor, and that audio can be then sent to an audio amp, which would be very much like a tuned RF amp, just built only for audio, and a speaker. It could go to a horn speaker, which was a very early way to amplify the weak signals from a radio, or it can go to your headphones. All right, so with that, if you're doing some really important work, say you're trying to listen to weak stations, let's say boats out on the sea, you're on the shore, and you're trying to get those signals for health, safety, finding where those sailors are out there. When they're expected to arrive at port is also quite important too. The gain, the amount you can multiply that signal that you're getting from the antenna or wherever else it might be coming from tended to be kind of small. Maybe 10 kind of small, maybe 20 times the signal you got in. Just to put that in perspective, we're talking picowatts of power, just immensely small amounts of power. And if it was watts, we would feel it every day, going out there like a blazing sun. But we don't. It's picowatts, so it's imperceptible. It's this sea of signals that we just walk through in our daily outings. So that's a weak signal. So even multiplying it by 10 is still, that's not very much power. That's not a lot of energy there. So one idea is, okay, well, let's just take the signal from one stage and amplify it again. And maybe that's not enough. Let's add another stage. So you'll see there'll be a number of radio designs that were called TRF, tuned radio frequency receivers. And what was very common with them is that they may have multiple stages of amplification. And each one of these stages, I would say maybe the early ones, may have had, and most certainly had, separate controls for adjusting the gain of each stage. Later radios that came out in the mid to late 20s, these might be all controlled together by a common band or a loop or a wire. Because they're all built the same, they should all tune the same, and they do, and that would fix it. That's a lot of hardware. So you have 1, 2, 3 tubes, and then you had whatever detector electronics, you had some coupler stuff here, you got this whole mechanism of tuning it all. It's a bit involved, and at that time vacuum tubes were expensive. So if you're already in for 3 tubes versus no tubes, you might think maybe there's another way to solve the problem. One idea that could work is a feedback amplifier. So each one of these things, the signal comes in here, gets amplified, and then sent out, which is a perfectly fine way to handle amplification. But there's something else you can do that's a little wild. So when I talk about the properties, they're, I assure you, much more sophisticated and complex because of this simple thought. Instead of just taking a signal, putting it through the amplifier, and having it go out, what if we take a portion of that signal, so here, taking it from that output, you put it through some sort of feedback control and put it back into the input? I think we've all experienced some feedback situation in our lives. And usually what happens is you take something like a microphone and hold it near the speaker of your amplifier, audio amp, guitar, whatever, it's going to howl in oscillation. And that's typically what happens if you just kind of blankly take an amplifier and just feed that input back into it. It'll amplify and amplify and amplify and eventually go into something that's called oscillation. And the whole detail why it goes into oscillations, a fascinating subject, and I really do recommend, if that's something you want to look more into, to look up feedback, particularly positive feedback, on Wikipedia, because positive feedback is how that radio works. But if you at least either experiment, learn, and or work up a theory, you can tame what will normally happen with this and get some very beneficial results. Say if we could find a way to make sure that's not too much signal that's being sent back into the amplifier, well then it may not likely go into oscillation. In fact, you'll know that if you take your microphone, move it a little further downstage, it's not necessarily in oscillation. It may have a little bit of a weird sound to it, but you'll notice that there's a different audio signature for sure. All right. So in here, we talk about the benefit. If we could do something with this feedback concept, then we can fix a real common problem. I have a kind of signal chain diagram of how a radio from the 1920s was typically put together. This would be one of these TRF receivers. Here's that coupler stage here, followed by 3 stages of tuned radio frequency amplifiers, and then there might be a detector tube, and then an audio amp. So this radio here may have up to 5 tubes, and then only have an overall gain of 27. Now, if we could take this regenerative amplifier, that is an amplifier that takes the signal and feeds it back into itself so that it's the same as what had been presented to it. Let's call that a regenerative amplifier. Here we are with our coupling. Again, this is coils, capacitor, something like that. And then we have that regenerative amplifier, the system that takes the signal and feeds it back on itself. That same, for other reasons, can also provide the detector function. And then the signal that comes out of that is ready for audio amplification, and then it goes to the headphones. In this system, we have 2 tubes. Here's another one. We add an RF amp, just a general broadband amp. It just doesn't have to be tuned, maybe just slightly for the band you're trying to operate. And then we have the regenerator, and then we have the audio amp. This has 3 tubes. You can also just use this scheme like it's a replacement for the detector. Here we have that coupling and the tune circuit here off of the antenna and ground. And then we have the regenerative amplifier detector, and you can just hook a pair of headphones up to it. So anyone who's interested in these sort of designs, you'll see that these vintage regenerative receivers might be 1 tube, 2 tube, or if they're fancy, 3 tube receivers. So this is a really powerful scheme. We can replace these bulky, expensive tuned radio frequency amplifiers. And if we jigger it right, we can actually even replace the old detector and just have our basic coupling, this circuit, and then go straight to the headphones. That's really quite valuable. So what we have on my apologies, thank you. What we have on the bench is a regenerative receiver. So we have, again, the coupling circuit, which we can actually vary the coupling to. Why we have to vary the coupling, it's kind of there's a little complexity with how this regenerative detector works. It's a little sensitive to what is being presented, so varying the coupling allows us to control that. It also can act like a rough gain control. It's not the primary one. When you're trying to shoehorn, or where you're trying to get as much functionality from one amplifier as possible, all of these things interact with each other. Changing this will change the character of the audio, which if you change the regenerative feedback control changes the coupling, which then means you have to go in and retune the tuned circuit. There's quite a bit to it. But what does this give us, besides a little bit of a headache and some more controls that we didn't have before? Well, first, it's going to give us that RF amplification. Instead of the measly amount, if we were back in the 20s, if we got that measly amount per stage, this excels it by hundreds to thousands of times. So already we're getting a receiver that is extremely sensitive. And this would have been the case when this was first invented in, I believe, 1916. By a method I'm not going to go into in this stream, it also provides a detection function. So we don't need that crystal and capacitor anymore. This will also, just by how it's operating, convert the, it's not going to convert, it's going to extract the modulation off of that radio signal and then give you the audio you're actually looking for. It has a side benefit of, as kind of the part of the nature of how a feedback amplifier works. It allows you to get a really sharp tuning characteristic. So let me come in. So I'm going to draw two graphs. One graph is frequency, and let's say that's 550 kilohertz, and that's 1600 kilohertz. So that's the AM band right there, right? And then we have generally signal, some property of the signal, its amplitude, something like that. If we look at a standard crystal radio, and it's tuned for my favorite, it's not my favorite station, but you can get it on anything. You can get it on a couple of bad filings in your mouth. And we tuned our crystal radio to a particular frequency. You know, it's going to have the most frequency to the 1030 kilohertz, but it's also going to be able to see varying amounts, not a lot at this lower frequency, not a lot this lower frequency. But let's say that we're trying to listen to something on 1050. Well, here's that situation again, 1050, right there. And it's not as loud as it might be for this, and certainly because 1030 is a very powerful station. Maybe this one isn't. But I might actually hear the audio from both. Now let's look at the regenerative receiver. And this depends on how it's set. So you can actually vary this to a degree to what you prefer. So 550, 1600, again, just like that. And my signal. Something about there. We'll see, not a lot of signal. If we really, it could be something like that. So we don't see a lot of signal except for what's really immediately around 1030 kilohertz. This property, that the kind of width of the response of your tune circuit, is called Q. So here we have a low Q because it's kind of a squat hat shape. And here the Q is high because we have this really sharp shape. So if you had something that looked like that, that Q is nothing. And if we have something that looks like essentially a pole, then the Q is very, very, very much more than 1, maybe 100 or 100,000 or like that. And that would make how the range of signals it can receive, the bandwidth, narrow for something that has a very high Q and rather broad for something that has a low Q. So the two controls that this radio adds, so let's say that the audio amp, and it certainly does have this, it has a control knob, and that's for volume. And this has a control knob, and I'm representing the control knob literally like a little post and a knob. I hope you folks like that. And that's tuning. So you have tuning, and that tunes where this line is, where the best response is, and you tune that for the station you want. Say if I want to listen to 1600, that tuning would shift over here. That peak would be over here. And then we can change the volume, and that's essentially like you'd expect. You can change the gain of this audio amp, which makes the signal, the audio louder in the headphones or speaker or what have you. Those you expect. The two new controls are the regenerative control, and then what that's doing is changing the amount of feedback from the output of this amplifier back to the input. And then finally the coupling. The coupling kind of works in crossing between changing the amount of connection of the antenna to this whole system, and in some regards also, unfortunately, acting to change the tuned circuit response as well. Like I said, you're getting a lot. You can make this part with just one tube, as I mentioned. This whole complex thing, just one tube, or modernly you can do it with a transistor, a field effect transistor. I don't know if you can do, yeah, you can do a bipolar. And you'll have a fully featured radio receiver. So what do we have on message? Apologies, folks. Great. Let's actually try it out. Okay. I'm going to turn it on. So what I've done to this radio is just, it is from the 60s. The components are in it are prone to aging, particularly what's called electrolytic capacitors. If these, so inside is, it's a little marble, it's an electrochemical system, but over time that material dries up and it no longer acts as it should. So at the very least, those components have been replaced with ones that will actually do what they're intended to do. I've also taken a look through, corrected any wiring issues. So this radio should mostly work like it did the day it was built. I do have to warn you, there's going to be a bit of a hum. That is a known, that is what I'm finding is an issue with this radio. All right, let's turn it on and see what's on there. So for anyone who's not familiar with vacuum tubes, as I turn this on, AC power is being applied into the radio. That causes a current to start flowing through what's called a filament in the vacuum tubes. This filament is actually very much like a filament you'd see in a light bulb, except it's surrounded by some other components that allow it to be used as a part, like a transistor. You can use it as an amplifier, and other things. So you're hearing this, there's this AC hum, and that might be something that's just part of this radio or about how it was built. I don't know, but it shouldn't stop us from enjoying playing around with it. Okay, so what do I have? I'm going to be trying to listen on the A band here. A band. I know there's a radio station about 1610, I think. And I've got this antenna coupling, the coupling control down all the way, the regen control down all the way, and now let's turn it up and just kind of hear some hum. So we want to play around with the coupling knob a little bit, see if that causes some change. Yeah, it does. If you pull it up, it kind of causes the audio to quiet there. Let's keep that. I know from experience that if you keep this all the way down and just turn up the regeneration control, that's going to cause that increasing amounts of feedback, which will increase the gain. It will improve the Q and narrow up the bandwidth it's listening to. So let's just turn it up and see what. Ooh, I know what this is. It's the noise from my my laptop charger. Okay, there we go. So turn it up. Okay, something's there.
Now,
Ah!
COVID, they gather on Zoom.
Videos from visits too. So tell me what you're going to do when you go home today.
Ted's test results showed years of memory problems
Okay.
as we had seen 6 years ago.
Nice.
The 90s.
So we've got a station there. Now, I think there's a jazz station further along.
I inherited any suggestions.
Ah, there it is. Okay. Okay, we got a little bit of jazz. I don't know how. I think that's about as much as I can do. I don't know. Well, listen to this. Okay. So I'm going to turn up the antenna coupling and listen to the tuning. Wait. Kind of pulls that tuning around a bit as well. Let's keep it there. So let me turn the regeneration control up. Oh! Alright. You know that situation where I talked about as that mic gets closer and closer to the amplifier, you're adding more and more signal back into itself. And then eventually, sorry, it bursts into an oscillation. If I just turn it up, it just gets worse and worse and worse. But we're back. Okay. So that oscillation that occurs here, that oscillation is occurring at and near the operating frequency of the, it's the frequency that we're tuned into. If you had this hooked up in, say, one of those one tube types where everything's being done by one tube, if you get into that mode, then not only are you receiving audio, the oscillation that's going in your tube just goes right back out your coupler circuit and out into the antenna, and then you're on the air too with your radio receiver. So often what folks would do in a design is add one tube, some sort of isolation between the antenna input, the coupler circuit, and the detector, and that would minimize the amount of that oscillation. Well, why even have oscillation? That seems like all the stuff happens here, you know, where everything sounds normal. Why would you want that? If I get lucky, and I hope so, we're gonna see why. So let's give it a shot. I'm gonna go to band B, and okay, let's see if we can do it. I have to admit, I have not had a ton of success with the little wire antenna that I have here. Okay. What I'm looking for is a special kind of signal sent by keys that are like, I'll turn it down a little bit for you folks, sent with things that look like, as I, oh no, I took it apart, oh no. Essentially Morse code. Morse code signals. So Morse code signals they really don't have a modulation. They're either on or they're off. I guess you could call that a modulation. It's on and off. But you can't pick it up so easily with a receiver that just picks up AM radio stations. Now I'm going to give it my try. I really will. For you all. To see if I can find one. I have to admit, I really didn't last time. And feel free on chat to ping me, let me know I'm doing something wrong. No? So once you've built one of these things and you're trying to get these sort of signals, this is what you were in for. If there's anything that anyone ever sees of this stream, is how much knob twiddling you do with one of these radios. But I'm not a confident knob twiddler like others. Okay. Let me try one more band. Apologies. Let's see. That was 4. Okay. Maybe something will be here. I'll give that a shot. Band C. Oh. Don't you think that this is like peak radio? I think it is. That you're like literally twiddling knobs trying to do your damnedest to get the signal to come out. Of course, us today you just turn it on and you tune it, and actually it doesn't even have circuits anymore. It's all a whole other technology, and it's just a miracle that goes on inside. Okay, so I'm gonna try to find something. Oh, nothing. No. More coupling. More coupling. More coupling. Not a ton. Not a ton. Oh. Can we do it? Oh. Oh. No. Let's try it again. Let's go down. Let's go down to go up. Okay. I think I'm gonna give that a shot. I'm gonna go over here. Okay, I just want to point something out. So the main tuning's over here. Whenever I go over to this knob, what I'm doing is kind of fine tuning. Here I'm on band B. Let me turn this down a little bit. I'm on band B. I have the pointer pointed at 4 megahertz. That's a 4.0, 4 megahertz. So this is doing that gross tuning. If I do here with that smaller capacitor right here. Here's our main tuning capacitor. Here's the smaller tuning capacitor. That acts with this one to allow us to get a finer tuning control. So you can see, if you happen to pick one of these spots that's marked with a dot, that if you do that and leave that one alone, you can tune more finely between 4, 3.9, 3.8, 3.7, 3.6 megahertz, or 3600 kilohertz. So that happens to be the 80 meter amateur radio band. So I'm looking for, and I'll give it one more shot. These radios do take a bit of finesse. You have to control, and a little bit with the audio. You have to control coupling, regeneration, tuning, because the tuning will drift as you change things around, and then finally the audio. Give it a go. But hey, it only takes 1, 2, or 3 tubes, so what are you complaining? It's not like buying one of those big receivers. And this kit, I don't know how much kids back then got as allowance, but I feel like you did a bunch of chores and projects and things and saved it up, that you can get yourself one of these. Nope. Oh. Shoot. Is that something? Is that one of the power supplies in the house? You're out there, I can hear you. Oh. That's kind of a burbly noise. You get that with power supplies. Come on. Oh man. Come on, Explorer, you can do it. Oh, Explor-Air. I know you could do better than this. Oop. No, power supply again. Okay. Not having a bunch of luck here. So we're gonna go on. I know. Oh yeah. I'm gonna turn it off. There we go. So you could spend an entire afternoon with your headphones or the speaker listening, just trying to get it dialed in just so. So I don't have very much antenna here, just maybe 20 feet going out of the workshop and running along the ridge of the house. So we probably should do better, but we do know that the radio is a bit roughly built. So what I'd love to show you is what a manual for one of these kit radios looks like. So what we have here is the Lafayette Explor-Air receiver kit manual. So in the box you get the individually packaged components, and you get this. You should probably get some big nice fold out, an explanation sheet about what these components are, how they're labeled so you can tell what value they are. There's a color code associated with a lot of these parts to tell you, oh yeah, that's the 47,000 ohm, or what's called 47K ohm resistor. That has a particular color code to it, and this tells you how to read it. But the really nice part, yeah, so there's I hope a parts list. This is going to be way more complicated than IKEA. Is all of these really detailed instructions, starting from the first step. Get out your parts, make sure you have them all, that's an important part, and put all of these parts here and there and there and there until one by one, solder joint by solder joint, and wire by wire, as you're going through, checking off each one of those instructions, you put it together. So we're going to actually be doing something very interesting today. We're going to take it apart. We're not going to take it apart. Maybe, yeah, we might actually do it by the end. We may put this completely back into a kit state, or at least all the parts that are worth keeping, and I'll talk about that along the way. But we're going to take this radio that is pretty much working and re-kit it. That is, take every part off and out and turn it back into a kit, and then over the next few streams we're going to put it back together. And what helps us do this is, versus if I were to take a more standard commercial radio and try to do that, is that first, this thing was built to be easily assembled by kids. So and the instructions are extremely detailed, as you can see here. Even probably, yeah, so you can see. It tells you exactly how to lie a wire, where it's supposed to go, because especially with many of these vintage radios, disconnected for you folks. With many of these vintage radios, where you route the wire, and this is the same with PC boards, though it's kind of locked in, where you route that wire can be very important. If you route it just a bit wrong, you can end up having signals either come off it and interfere with other circuits, or similarly it could be impacted. And that may be why we're getting some hum here off of this radio. So you saw the nice view in the manual, and what I'm going to bring up now is a view of all the stuff under the chassis. We've got a lot of stuff going on. So first of all, there's all those wires that are being talked about in the manual. They're all routed here as well. Right. Just a moment. I'm going to find myself a nice non-conductive pointer. All the wires here. We have other components, like we have these yellow discs here and here. Those are ceramic capacitors. They're a very basic electronic component. They hold a charge. We have these brown cylinders. Some are larger than others. They're resistors. And you can see that color code too that's being applied to them. That color code corresponds to a resistance value. These are made in a standard set of resistances. So let's say I want to have a, I believe 2.2 million ohm resistor in the circuit. There's one right there. Now you can read off the color code. Red, red, green, silver. Red, red is 2.2. The green means multiplied by a million, and then the silver tells you the tolerance. I think silver is 10% tolerance. So if you buy one, you're assured that you're going to get a 2.2 mega ohm resistor plus or minus 10% of value. And then we have stuff like this. This is, no, it's not too hot. This is a power resistor. So inside here, there's a very fine coil of nichrome wire, very much like what you find in a toaster. Actually, this works almost exactly like a toaster. There's a fine resistive wire. Nichrome is a kind of resistive wire that's wound on a cylinder inside, and then it's put in this ceramic case, and then some ceramic, I don't know what that is. Is that porcelain? No, it isn't. Some other material that's baked on, and then it forms a really, it's a resistor that can handle a lot of power. That is, resistor's main job is to drop power, drop voltage. And in fact, that's what is being used here. This is part of a circuit for powering up all the tubes. The way it's built, and we're trying to avoid using something large and bulky and expensive called a transformer, you can have these tubes all put in a string, and then what's called kind of ballast the remainder with that resistor. And then all told, if you have this tube and this tube and this tube all daisy chained together with this resistor, that you can run that directly off of 120 AC. And in fact, that's part of the design of those tubes is being able to be used in that way, so you can make these really low-cost, minimal radios. And then we have things like, there's, for you folks, sorry. We have a headphone jack up here, and we have the controls, which are usually either, this is a rotary switch, makes a really good clunk there, and then this is what's called a potentiometer. It's a variable resistor. That's what inside. There's a little wiper that goes across a conductive pad of carbon. So I'm drawing it off there. There we go. So you have, this is the case of that potentiometer. Here and here is a connection and connection. And you can use those. If you're looking to have a variable resistance, you would connect here and here. So this is a wiper. This kind of sweeps across this material, this carbon material from here to here. So let's say you connect up to plus 12 volts and down here to ground. We would expect that if you measure the voltage, and this is turned all the way this way, you would see that being 12 volts if it was turned all the way this way. If you turn it all the way down here, it's going to be 0 volts, ground. And anywhere in the middle, then it's going to be something in between. And that something in between is kind of proportional to how much you rotate it. So similarly, you could do with these DC voltages that I represented here, you can do the same with signals too. So we have one potentiometer. It's actually built into this combo control and on-off switch right there. That's our volume control. And then they use a potentiometer for the regeneration as well. All right, so what I want then to do is just show a lovely website done by an enthusiastic owner and restorer of these radios by the name of Mike Simpson. He does a page called analogdial.com, which covers a number of very similar projects and radios and kits. And this guy, he built one when he was built one as a kid. Later found it and restored it. But since that time, he's also worked on a number of other ones as well. And I just want to show it's a real delight of a website. It goes into good detail about what they looked like, the kind of varieties, because this kit was made for a number of years through the 60s and I think the early 70s, according to his research, as well as his restoration work. So here we see one of his projects, and boy, does that metal shine. They don't come like that. You'll see this one's tarnished, and it's been really, really neatly wired together. Ah, there he is. And this is also, hey, Mike, if you're watching, I hope you enjoy this. That's a cute picture. And I like all the tips. And by the way, thanks for the assistance. And I look forward to getting your package. But even then, he's found, this is a first, he's found evidence that this radio was used in the Apollo program. So here we actually see is this the command module? Yes, it is. And if we look very carefully, I'm looking in the picture now. Where is it? I think I see it. Hold on. Oh, wait, there it is. There it is. It was there the whole time. Look at it. It's right there. Smack in the middle. All right. Good, simple, robust circuits. Am I surprised that they used this radio on the Apollo program? I am not. You heard it here first. It's undeniable. And I really must refer you to analogdial.com/KT135, and you too can learn the evidence about this secret history of the Apollo space program. Okay, so let me cut over to that manual view. Let's go to the next. Sorry, we're back. What we're going to do over the next hour and a half is take this radio apart. You're going to see something you almost never want to do as a radio restorer. Unless you are looking at a radio that has some major construction problems, or is something like this, where it's fairly basic. It was built to be very simply put together, and it has other issues. Or if you're like me, I'm just doing it so you don't have to, and you can sit back and watch me do it. Well, otherwise, it's not something you want to do. You do want to work on the common issues for a vintage radio. That's always electrolytic capacitors. They fail. They're no longer the things that they say on their tin. Paper capacitors are exactly the same. They are no longer what they say. Quite often, resistors will also drift in value. So you have to suspect not just that there might be some issue that caused this to be put in the closet, which it's old and I have a better radio is totally a valid reason. That's why often these radios are put in the closet. But it also may have been that there was some issue. You have to add that issue to all the other issues of just all these parts changing over time. It's amazing to think, because it's not something we, in the younger generation, have had very much experience with some types of electronics just having components that degrade like this. Usually it's kind of on and off. It works one day and then bam, it's dead. It's dead forever. You can't get it fixed. It couldn't be fixed even if you wanted to. Not so here, but in exchange, there's a lot more stuff. It's bigger and bulkier and heavier, so there's definitely a trade-off there. So what I'm going to try for, so what I'm doing with you folks is I'm thinking through what do I want to do, because if I wanted to take this and take it apart and turn it into a bin of parts, I could just go in with my side cutters. By the way, I'm not going to touch the components yet. There's a reason why, but I can just go in with my side cutters and hack, and free up all the stuff individually and pull that out. And again, I'll have to give it to Mike. I saw this interesting idea, and I think that's what I'm going to try tonight. I'm going to try to remove all of the connections to components. Let me think. Yeah, I'm going to try to drop all of these electronic components out as one wired mass. Because what I'm looking at is that all of these connections to the chassis are made with screws. I don't see any time where they make a direct solder connection to the chassis. So if I undo all the screws, that should loosen all the middle stuff, including these two sockets. And those two sockets come out from the back. So that should work. And if I undo all the bolts that hold, all the nuts that hold the controls in, that should come free too. If I do the back, I'll have to cut that line cord and undo the antenna binding post here. How about the top? What do we gotta do? Let's see. Alright, well, I probably have to unsolder this. So there's wires from this transformer that go to the chassis underneath. Connection to the speaker will have to get undone, as well as these two parts. What's really great here, if this was a commercial radio and I was doing something like this, I would have to build up a really good set of notes as I undid it. But I don't have to. I have this really detailed manual about how to do this. What color wire goes where to put it. So I don't have to care about that too much. Okay. I do want to show one thing. This radio, in addition to needing some of its capacitors replaced, it was missing that coupling control component, which was a variable capacitor, by the way. And let me get the non-conductive one. Okay. So right here is a new component that I put in just to get the radio working. When I got this, this was in a pine wood box that had a bunch of other tuning capacitors and other things all kind of jumbled in the back in place of what was supposed to be here. So there's a small variable capacitor that goes there. It's used to adjust that coupling like I've talked about. And I think I just have that on VHB double stick tape there and just tacked to the circuits it has to go to. Maybe in time I'll find the actual replacement, or I can come up with a way to mount this one, because it does work well. It fits the knob, and it has all the same value that the original part had. Okay, so I'm gonna quit yammering so much, and hey Mike, it's good. I'm glad to see you. I'm just getting to the part of getting the radio out. I'm going to change my exposure. That's better. Very good. Let's free this from the chassis. So I'm going to see, for you folks, I'm going to probably do something like that. And I'm going to use these. I don't know if you folks have seen them. I was glad when I found this at we have an appliance store here just up the road, and these are rubber damper blocks used for washing machines to keep it from walking on a slippery floor. I like to use these, or I like to use rubber hockey pucks, just as a really nice, bulky, rectangular, square, or round, doesn't matter, bolster. Great. I hope you all can see that and that you'll enjoy. Before I get in there and try to start taking stuff apart, I'm going to discharge the electrolytic capacitors. So these are components that are used as part of the power supply to turn the AC into DC. Later on, when we start to build this back up, I will talk a bit about how those power supplies are constructed. So what I have is an insulated wire and a little resistor. I'm going to go in and contact the point that may still have charge on those capacitors. Because if I just started hacking at it right now, actually, yeah, I might contact a higher voltage than I was expecting and get a nasty shock. So I'm going to go in, I'm going to touch that to ground, and that should, wait, this is not chassis ground, is it? I have to pick a different point. Where can I get at that point? Right. Okay, let me do that. All right, here we go. Now, it shouldn't be a real big Zorch. I have a little resistor. I just current limit it. And it's usually, if you just did a wire to wire, you'd probably see a pop and arc and the like. So just make sure that's nice and discharged. This likely doesn't need it, but I'm gonna feel better if I did it. Okay. It's my radio. I get to do what I want. Now, if I take my radio and I do a bunch of stuff and then I try to pass it off as something else to people when I sell it, that's not nice. Which people do. My first stream was repairing a Ten-Tech, that had been what's called golden screwdrivered. Someone thought, you know, they knew what they were doing. So they went in there and they tried their best. It didn't work out. They left it half done, but then sold it as worked the last time I used it. Okay, sure. Thanks. All right, those should be pretty well discharged. What I'm gonna do also is I'm gonna have two things on the side. Let's take a look. Should have, and if you ever attempt to do this, which again, I think if you are attempting to do this, you don't need this instruction, but you should probably have a printout of that parts list like I have here, just to see what's what, and to keep track of it. Again, this is simple, and in the end a lot of these components are getting replaced, so it's not too bad, but it is good to keep track. And then also you'd want to have egg carton. I got 2 boxes off to the side here, so as the parts come off I'll just put them in there to keep them nice and safe. And then lastly, what I'd like to have, and you can get something in bulk, is shoe boxes. So I have plastic shoe boxes all over the shelves here. That I use for carrying different projects in process, just to keep from things rolling around. So if I just kept that if I just kept the egg carton in the bench, oops, I hit it, oh no, now all the parts on the floor, no way, bad news. So instead, just take these and then put them in the shoebox. Okay, so it's discharged. I'm pretty sure I'm safe. I'm gonna take this camera away here and we'll work from the top. There we go. So great. What I'm going to do is desolder some of these components that are on the top. So those wires, they're going to stop us from being able to just pull this thing completely out and away. So I've never done too much soldering on camera. I usually have my face right up in it. So you'll have to forgive me if I don't altogether do the same job. I hope you forgive me. I think you will. There we go. So what I'm applying there is desolder wick. What that is copper braid with a bit of flux. So when you touch that and the soldering iron to an existing well of solder like we had at this joint here, that activates the flux, heats up the copper, and then you have the perfect conditions for that solder to wick up. That's why it's called solder wick, into the copper braid. And in that way, it's now pulled away all that solder. Oop, there we go, that's free. Pulls away all that solder, and then we can go in with cutters and the like to free the components up. So this radio had something wired over here before. So there's 2 loops I'm contending with. There was that old wire from that other variable capacitor that was tacked on the side of the box. So whomever had this was doing some experimentation, which was nice. I mean, you get the radio, you play with it, and it's, you know, pretty good. And then wanted to try out some new things. I don't know, maybe add some sort of additional tune circuit, change how it tuned. Maybe something went wrong with that little coupler part, which is why it was missing, and there was a whole other variable capacitor built into the box. That could be it. So that's free. Okay, so 824. I don't want to do 3 hours, so let's see what we can make hay with. And there, and there. I'm imagining happy little clouds, aren't you? There we go. And sometimes when I get a little loop like that, I'll just, again, I know I'm replacing all of the wires. Oh, we were able to save that one. That's not too bad. Okay, so now that part is free of the harness. Now it's just however it's mechanically all built into the case. All right, take care of those speaker leads. Whoever did this, they did a decent job at parts, but you can see when they were working with the soldering iron under the chassis that there are parts that do get tight, and if you don't have a really nice narrow soldering iron, the right power, you end up having to get in these situations where the soldering iron, like, I'm going to do this because I'm replacing the wire, but yeah, they touch the insulation, so now it's burned, and it's also thinner there, and it's also black, so that's not going to work great for insulating it. Okay, if I can just get my ratty. So I'm using some, I have different levels of tweezers. This is the ratty tweezers. So like this is the last thing, their last stop of the tour. They come in, they're new, they do only the fine things, they do the surface mount components on PC boards that I work on, and as they get kind of beat up, or they suffer because I had to quickly throw them in a Pelican case for field work, they get a little beat, and then at the end they come in and help me with the fine stuff. I like it better than the needle nose. And then again, I never pay too much for needle nose. Maybe if I just got a really good one, I wouldn't have so many problems. Right, I should probably also take out these tubes. Just keep them. Let's see what we have. It's not, the label's kind of gone. It sort of says RCA. We have a 35W4 made by GE. I wonder if we can see what year. I think that's, I'm gonna guess. 63-22, the 22nd week of 1963. Maybe. That sort of sounds believable. And then finally this tube, the one that does all the work. No, it's not the only one that's doing all the work. No, the other ones do too. All right. We have a 12AX7. It's made by Amperex, and it has a cute little bugle playing. Let me change the focus. There we go. A bugle playing vacuum tube. I love the art on these things. And unfortunately, because if they've been operating for quite a while, this labeling is really fragile. So if I went and wiped them, for the most part, all of this ink will just wipe right off. So all I ever do is kind of wipe the top with a little something, be very careful, just a light dusting with a brush if I want to keep the kind of that tube art. Okay, so that's free, that's free. I need to get those out. Okay, boom, it's done. I didn't even have to use the soldering wick. I don't have to use it when I'm trying to remove a real bulk amount, or I have a really tight loop. So, like I have here. There it is. Yeah. Okay. And I do want to be careful. I don't want to break that. I had a hard time finding or trying to find a replacement capacitor for that coupling control. I bought two on eBay. Neither of them fit at all. I ended up with that more modern plastic-based polyvarican, that's what it's called, and it does okay. Just, you know, it's not something you would necessarily have put in 1963. but it's okay. It gets to be a radio. That was the point of the radio, right? Oh. Hey, Mike. Thank you so much. I missed that. Yes, it really should be. That's supposed to be a 12AT7. I don't know if I have a 12. I think I got it. Yeah. 12AX7. Huh. Look at that. Okay. So we actually have on chat the fella who's a big fan. Hey Mike, thanks so much. And I have two other viewers. I think one of them's me. One of them's me. Okay. Well, Sarah Joy, if you're watching, I hope you enjoy this too. You don't have to buzz me. I got the text, but thank you. Okay. I think that should free it up. So let's take a look. Right. So anything, those should go drop down. Those should go drop down. Okay. Okay. So question. What's the difference? What's this difference between what we're seeing labeled here, the 12AT7, and this guy? Okay, so each of these tubes has a type number. It tells you, and that type number associates with, okay, it does this function. It's meant for this use. And if you buy one from RCA, let's say one manufacturer, you should pretty much get the same characteristics if you get a 50C5 from, let's say, another manufacturer, GE, for the most part. Occasionally, there's some more unusual, very specific type circuits that had to be more specific. But generally, what you were trying to get is that if you buy a 50C5, you get certain properties. So 50C5, that's used for audio amplification. So we have three tubes that came out here, here, and here. And we know literally from what's stamped in the chassis what those types are supposed to be. We have 50C5, a 35W4, and a 12AT7. Well, we found in the other two sockets, they're what they're supposed to be. That is what they are on the tube. But there's a different type number for the tube I found in here. This is a 12AX7. This is supposed to be a 12AT7. They're sort of similar, you know, but there's some slight differences in their properties. So I believe, I remember the schematic, a 12AT7 is a dual triode. That means inside the body that, and actually you can see it in the 12AX7. Okay. That you actually have these two, a little hard to see, but you have these two structures. In fact, in this tube, they're really kept separately, but literally one and the other, they're what these functions called triodes. 12AX7 and 12AT7 are both dual triodes. They have slightly different characteristics, though. And according to Mike, again, thank you very much, that the 12AT7 is going to have a characteristic that may make it easier to operate the regeneration control. The 12AT7 being, as he says, hotter, or kind of having a more higher gain characteristic, but may otherwise kind of change how it operates, how this was intended to be. I don't know. It does work, so nothing too bad. We can actually try, if we get a 12AT7 and see what the difference might be. We could literally swap them one for the other. Okay, getting back to the disassembly, the only thing we have left is this transformer. It has wires that come out of the bottom of it. So transformer is, this is a small version of what you have up on the pole, that on one side is a coil of wire, on one side of a loop of iron. You can actually see this kind of metal over here, there is a loop of steel, iron, and there are two coils. That's what's inside this paper wrap. And what that allows you to do is to couple a alternating current from one side to the other, and usually with some change in property. If you have the windings be the same number of turns out of the same wire, then that's what's called one-to-one. Whatever AC signal you put into one side pretty much is what you get on the other side. There's provisos, there's a lot to electronics, but in general that's what you get. What this transformer is meant for is to convert the output. This is again more complicated, but you'll remember that speakers and things, headphones, let's say speakers, they say, oh, it's this speaker is 8 ohms or it's 16 ohms if you get some real fancy speakers, and they have to be hooked up just so on the output of an amplifier. Similarly with the amplifier that's used here, but it's what it's expecting to see as a load, whether it be the speaker or something else. What it expects to see is very different than what a speaker or a headphone looks like. So what they do is they actually use a transformer to convert that AC into a characteristic that's more appropriate for the speaker and headphones. Really, the term you're looking for is impedance and impedance transformation. It's not really going to be a electronics educational channel. I do just want to highlight though that there's some important components, what they do as we go. But more importantly, we're going to have to get it out, and it's going to have to come this way. All right. Where are you? So we're going to look for is the 4 wires to come off that transformer and undo them. So it looks like we have 2 over here. Let's see, there's one, sorry. There's a set of leads here, and there's a set of leads just under all this stuff here. Looks like black and green. Take a look. Yeah, that looks like black and green. No, that came from the speaker up top. It's white and black, the really thick white and black over here. And then blue and red is over here. So if I undo those, I should be able to undo the bolts, remove the transformer, and get it out. Okay, that looked, you can sort of read and watch the how one of these terminals is so what we have back over here is the tube socket, and it's a fair warning, these sockets are not very, the leads coming off the sockets, so the lugs are not very strong. They're likely to fracture off. I'm going to see how much I can save just by being careful and using some desolder wick. Okay. Very good. Let's see. Now, I try to be careful. If I was doing restoration, well, first of all, I wouldn't just be kind of hacking at it a little bit like I'm doing right now. And I'd also be very disciplined about where all the little bits of wire went. Whatever got cut, I go chase that down, because you get a little blob of solder, a little bit of wire going to the wrong place, and it's getting stuck there. That might short something out. And if it shorts out something like one of the valuable, like don't point things with a soldering iron. if I had something go wrong and it caused one of these components to fail, these other cheap resistors, capacitors, I can buy replacements. In fact, I will be buying replacements. But one of these, I would either have to rebuild it myself or find someone with, it may be damaged, is what I'm getting at. It may be damaged and I have to replace it in some way or rebuild it. And some components are just they're just so difficult to try to do that and try to avoid it by being very disciplined. And that's not discipline that necessarily even came at the factory. I was looking at an old NC98. You know what? Why am I making this harder for myself? And as I was going through working on it, it had many cut leads. So when you put one of these things in, you know, wrap it over, you kind of cut the extra off. All those extra lead pieces were just stuck, let's say, under something like here, maybe under a capacitor, maybe jammed up underneath the kind of flange of the capacitor socket. Just a mess. It's amazing that they didn't have issues. Otherwise, this is beautiful radio, very well constructed, high quality components. Didn't give any issues on it until the day they stopped using it. But underneath was this mess of little cut wires and things like that. It was amazing that it didn't have problems. Okay, I think this is one pair here, and there's another pair over there. That should free it up. So if I go in, so I think I noticed I'm about to use the I'm about to loosen these up here. And flatheads, I have a kind of range of screwdrivers that I use, and usually comes down to the specific width and thickness of the blades and the hollow grinding. Some blades fit better than others, so what you want to try to do if you pick a flathead screwdriver to remove is to pick one that matches the width of the screw head. So if you come in with something small like this and it's a bit underfilled, and you can actually, I don't know if you can see that, but each one of these have a little bit of kind of biting in the slot. And that usually comes from a flathead screwdriver that has an end that's ground down too thin for the slot, and that the width doesn't cover the whole width of the screw head. So I end up with a wide variety of flathead screws, and what I found worked best on these screws was the particular insert blade for a Leatherman Skeletool, which by the way is it's a nice shop. It's a nice shop. Jesus, nice shop tool. Okay, I had a screwdriver that is a real, standalone screwdriver, but it gets used on my house. So it's out in the shed, ready for doing that sort of work, and the one that stays in here stays in here. So just want to get it enough where it's going to loosen up, because I'm already seeing, yeah, it does fit, so it's going to fit great on some of these other screws, but right here, not as great. Let's see what else we have. I feel like a lot of work like this comes down to building a good set of tools. This is just my pull kit that I always have at the side of the bench. And having the right tools, the right chemicals to do the job. And the effort of building that up is usually one project after another. So out in the shed, I also have a pile of, let's see, I have lacquer for brass when I worked on a radio that had a brass label. I have all sorts of flat black paint. just the amount of paints I have. I think I have paints that are for this specific weird dark green that was used by a company called Heathkit, and it doesn't quite match the house. It could, but it's just not quite there. Okay, so that's loosening up nicely. So it's not going to usually come free. There's a bolt and maybe a washer underneath. It's just gonna loosen up, which is good because I don't want the nut to go flying just yet. All right, back underneath. And there's one of the nuts under, kind of running it with my thumb there. And there we go. Got the screw. Put that in my egg carton, get my nut. Okay, and there really should be a nice star washer along with it too. Okay. One more, and we should have it free. I think I see it down there. Take my ratty tweezers. So there's life for ratty tools. So I have the ratty tweezers, and that's one thing. I also have the ratty X-Acto blade. The ratty X-Acto blade kind of takes the place of what you think you might do with the knife if you wanted to get between two very fine pieces. You don't necessarily want to cut it because the blade's, you know, not really, it's kind of rounded over, it's not going to do it. But it is still a nice flat, very thin, sharp edge, you know, fine edge to extract things. One I think I've used it in the past to use to get between two shells of a garage remote control or something like that, and I couldn't really get a screwdriver. And if you take a regular screwdriver and kind of jam it in there, it marks up the edge. You know, it looks like what I was talking about with the screw heads. There we go. All kind of bitten looking. Okay, so there's my screw. I should have a nut and a washer. I can see them down there. Nut inside star washer. I do want to account for those. Out, and there's those two leads. And these were shorter, and they should just come out just so. And there we go. That's our transformer. Okay. Put that off to the side. What else? So that should free everything that's on the top from the bottom. That will slip out. That will slip out. All these parts will stay. Now the bottom. So one thing, which is fine because I'm going to have to replace it because it has nicks and cuts along the way that I had to wrap some tape on. We'll take the AC cord off, undo this clamp here, or maybe just cut it on the inside. Undo these nuts for this stuff. This is the headphone jack, and this is the antenna terminal. Actually, yeah, like I said, right there, antenna. Let's do that. Oops. Get my rubber blocks. Okay. Okay, there. Here. I don't think this was particularly, yeah. I think I had to hack around on this, so we've done that. Boom. So this can stay, that's fine. I mean, we can take it off too, that's not a problem. This is an insulated binding post. We'll get to the insulated part in a bit, but underneath you could fit and wrap a wire here and then turn down the nut, and now it's captured. And you can see a hole where you can actually pass the wire and then do the same. You can also use, and I don't see them very much anymore, but headphones of the vintage of this radio and older had these really fine pins that would just about fit here, and then you could bind it down, and that would work. And you can use spade terminals and the like. So this is insulated from the chassis using these washers. So here's a plastic washer that the nut goes through. And that really nicely stands it off from contacting any metal here. And then there's an additional fiber washer that's added to it as well. And that, all told, allows the antenna signal to make it through without contacting the chassis and getting shorted out. So let's put my nuts, if you can, and I'll do this with the transformer off the stream. I'm going to put the nuts, actually let me just do that now. Put the nuts for the part all together with it so that it all stays together. You don't have to wonder. Let's do that with this. So I can put the screws in, although I may ultimately just replace the screws. So then I just will end up taking them off. There we go. I'm holding it. Just get that out of the way like that. Put my parts back on. Right. And now I don't wonder, where did that screw go? It's here with the transformer. Don't keep it too, loose, because it'll just fall off. There. Now I know. And there we go. Okay. What else? Yep, that AC cord. Like I said, I'm just gonna cut it, probably just on both ends. Cord's no good anyway. Just made it work for you guys. Glad you enjoyed it. And let's see. Get a pair of these, and we're going to follow the instructions. This is actually written about in the manual, taking a pair of pliers and just easing it closed, which closes this clamp. It's a nylon, well, not specifically nylon, but it's a plastic clamp that holds it and locks it in place. So what we're going to do is I'm going to crunch it down and then push it through to pop it out the back. Oh, sorry, into the chassis, not the back. Okay. Take a look. Might be, but it's going to be hard. Now, thankfully, they still make these, and they look pretty much like this to this day. So, if I wanted something that looked a bit better, or I'm looking at it off screen, I don't care. You know what? That's probably my mistake. Maybe they should be coming from the inside out. Okay. Let's see if I can give that a shot. Oh, there we go. Got it. There we are. So you can see, that's the line cord. Let me just do it again. Whew, it's trash. Take that line cord, and you pass it through into this channel that's into the grommet. That's what it's called. Push that down. You're gonna really have to push it down to fold this up. And it makes a really tight bend in it. Like, that's what's going on inside. Really tight bend. Put it back. And then with pliers, insert that like so, mash down with your pliers, and this will slip in and the chassis metal will fall into that notch. And then it's not going to come back out. And it's certainly not going to slip from the grommet because it's being held in this really tight bend. The grommet came out okay. I'm going to keep that. And old cable that, where's that tape? Yeah, there's tape on this thing. It's trash. I already know because I have the parts list that I need to go buy a new one. Okay. Then we're going to get this headphone jack out of there. I think that's a half inch wrench. And oh, it was already kind of loose. And this similarly is insulated. There's a fiber washer right here, and I bet there's also one inside too. Oh, there we go. Just try to keep them in the same order. There was the nut, then there's this washer, and then there's the fiber washer. I'm gonna put those aside, and then out comes the headphone. So this headphone's still, it's actually not hooked up to very much. Okay, yeah, it's going to the speaker up on the upper part of the chassis. So we can take this piece out. And then there we go. Keep that all together. We'll work on this later. We're going to get those wires off soon. So that is everything off the back chassis. So now we just have to handle the front, including the front panel. I want to be careful with that because that's where all the silk-screened legends are on. So I'm going to do so this does from the Boxborough Hamfest. I think I got it 10 years ago. Yeah, I think it was 10 years ago. Gonna remove, it's perfect. Look at that. It's the right blade width, the right blade hollowing and everything, and then off come the knobs. The knobs I put into their own egg crate. Where's that egg crate? Because it's all, these are all the nice polished things. I don't want it to get all scratched up. There we go. Off come the knobs. And I don't back the screw all the way out, just enough to get them off the controls. There's the same thing about keeping the screws on the parts. And then off comes my wacky replacement. There we go. You can actually see inside. On the side, there's the screw head. There's a screw that runs through, and as you screw it down, that grub screw then bites into the shaft of the control. Nothing to them. Okay. So what I have to do on my radio is I gotta clip out, not clip out, I gotta unstick my replacement capacitor because it's stuck in with this fat, flexible VHB. It's made by 3M. Double stick tape. So you can actually, it's a double stick tape, so not just something about the same thickness of Scotch. This stuff here has some real thickness to it. Look at that. It's gummy and it sticks to flat surfaces really well. In fact, they use variants of this tape to hold panels to the side of buses and cars. So that part's free. Now I just got to get these three. And I'm pretty sure it just means undoing these three nuts there. We're also should be able, I don't think, do we have to do anything there? Yeah, we do. All right. Let's undo these nuts. If I'm trying to be very careful, I might lay some tape or maybe some wide washer here. If you can hit it with a little bit of finesse, make sure not to mark the panel. I don't like using the sockets because you can't see how close they get to the surface. Even though the end of the socket is rounder, I like to just gingerly come in and see if I can do it without putting any tape, or if I put some tape on there just to keep from ever contacting the paint surface. You can see what happens just from the marks of previous work. Like here's one here because the knob was too butted up against the panel. You can see small marks here from someone using this type of tool for the task. And off that comes. That one's not so good. And guys, don't let me forget to put the nut on there. Okay. Thank you. Oh boy, are you joking, right? Yeah, I'll try this one. Maybe this one's easier. Oh man, why'd you have to wrench it so hard? You didn't need it, did it? Okay, there we go. That one I probably should have put tape. I don't think I marked it, but I really wish I had. And now this one again. And again, one of the things I collected along the way was just a ton of these little old wrenches. Because often you want to, if you have some unusual part or problem, you want to take and modify the tool so it fits in that tiny crevice or something like that, if you have that problem. I like to be able to not feel bad that I've just spent it with one of my parts. Okay, that panel now wants to come off. I'll hold it back. And I got to take these two knobs off. And off that comes. Boom. So you can see this was made of a white plastic here. I don't quite know what that material is, but oh boy, take a look. First of all, it's kind of ratty, but it's non-conducting, and the big deal about that is that regeneratives are kind of sensitive in their tuning, so you often want to try to isolate your hand, which is in itself acting like a combo of a capacitor, a little bit of an antenna, a way to couple noise in to your main tuning capacitor. And similarly, they don't do too much on the other one. The main tuning capacitor really has that isolation. So there's the knob. Came off with all the nice stuff. Okay. And then this one, that frees that. Boom. There we go. Yeah, if I felt right, yeah. Okay, hold it up. And what do we got? There goes the front panel. There we go. So I bet what happened is that this would be specially wrapped in some paper. I also see some of that kind of age and damage. I mentioned the scrapes on here. Try to get the angle where you can see it. There's a thing that happens when radios like this are these painted over silkscreen panels are kept in wet locations. You get this bubbling and rust underneath wherever there might be something of an open edge. This one particularly has it on the upper edge. It's not too bad, but this panel's seen some things. It's straight though. Okay. So I have two components left on the panel. I've got the main the speaker, and I've got that band spread tuning capacitor here. See? That tuning capacitor looks a bit loose. Why is that loose? Is it screwed on right? It is. Okay. Oh, it's the actual rivets that are in the part. It's a bit loose. Okay. Let's get my Leatherman, give that a shot. Oh, shiza. So this is definitely one where I would start to put some tape. Now, thankfully, my little scratch is just because I'm so excited to show this all to you. And I just know this from working with this panel. I'm not going to press too hard on where that silk screen is. I just need to protect the area around the tape, because there is not a nut on there. So I'm pretty sure I didn't see a nut. Those screws thread into something that's built in that part, so I do have to turn those screws. I don't get a choice of just backing it out the other way. Let's see. All right, that's too big. Let's try the other one. I wish I could get a regular, no, actually I probably could. I wish I could get, at my price, the regular screwdriver that matches how good the blade on this skeletal is. So those are really tight. But there we go. And then once they're loosened, I can go with something else. It doesn't have to be too bad. Yeah. Okay. Was there a nut? Oh wow, there's something more back there. Okay. See that in a sec. Oh, there's spacers. Okay. So how off comes the part. There's our fine-tuning band spread capacitor, and it actually many of these almost all of these parts are labeled with the actual part number from the parts list. Let's see, that's 1256, and let's see, capacitors. The band spread capacitor C1 is 1256. So there it is. Really nice when you're working on one of these kits, especially when you're doing what we're doing tonight, which is to rekit it. So just so we don't lose them, let's see, one had a star washer. I don't see the other star washer, but yeah, you can see whatever rivet nut holds that together is just kind of loose. Let's see, that's, oh, my apologies. That says ASP. I don't know if that's, might be the type. No, almost certainly is the type, because it kind of looks like one of those other types. I'm trying to remember. Oh, there's the lock washer. Sneaky. Okay. Again, I'll just put it together like it came off, and then I know how that works. Okay. Cool. Now there's just one more part to get off the panel. There's the all the screws that hold the stuff, and we actually should be able to drop all the electronics out, all the remaining components, but for one part out of the chassis, and that's going to look dramatic. And then we'll get to chopping the bits and then call it a night. There we go. Ready to go. Put down my parts. And easy, 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 easy. I would never do this for dials printed on glass or something like that. But here we're stuck. We have to get that screw, and it was wrenched pretty hard, so now we're clean. No damage. All right. I might do that with the nut driver. It's on the back. There's no paint here. There's just the plating on the steel frame of the speaker. So here you can just totally use a nut driver. No, it's not going to be the right size. Let's see. It's likely going to be one of, let's see. Yeah. Oh. Now we get something to counter it from spinning on the front, because that's definitely going through the paint. So let me just hold that. And here's the nut driver. This is really just hand tight, and that's just loose. Put the screwdriver to keep it from rotating, and then again, just loosen it up, and the same all around, and then do that while holding the panel. I can make it a little easier, but I want to show it to you guys. So there, it's loose, not bad. And then finally, another one. I wonder if 20.8 is the part number. I don't know. Okay. There we go. Really not even that tight, but I don't want to attack them from the front. Because that panel, I do not feel like making a new front panel. Could. I mean, I thought about it. Like, how would you make that? So I would take it and scan it, and I could by myself paint. Well, first of all, you're going to strip it down, and then you would do the two-tone paint, right? So you get the gray, light gray, dark gray, and then all this other stuff. This is silk screened on. I think I could do a silk screen. That would be kind of a project. You have to really, really, really like that radio. But it could be done. Could also make, this is less than smaller than a sheet of paper. You could print an entire self-adhesive label here. If it wasn't for that grill is a little tough. Maybe you could cut it back at that point there and have some matching paint underneath. I don't know. All right, so the panel is free. It's back. It hasn't been like this since I don't know, sometime in the early to mid 60s. It hasn't been free. And now it is. Put that in the very special area. That's going to go in a folder with some wrap on it. And again, just so don't go nuts. Just put these back on. Okay, so that's the panel free. And next we're going to go to the chassis. So one of the things I wanted to do with this stream is that I'd otherwise be here working on the radios. I wanted to allow you to join in. I wanted to join in. I belong to a club, and maybe you've had a club like this too. They would meet once a week, and folks from across all walks of life would work on something in common. For me, it was the Tuesday night workshop with my buddy Len and Howard. We'd go over there, shoot the breeze, work on our projects, talk about how work was going, and the like. And with COVID, we're all stuck home, and I actually set up this stream so that they could enjoy what we used to enjoy, and I hope you enjoy this too. All right, speaker is free too, and that's gonna go in a nice place. Chassis. So we're gonna undo some screws. Get to that. So if I undo, okay, if I do the flatheads that hold the main tuning capacitor on, that frees up some parts here, and then everything else looks like it works from the top. These parts are already free. Oh, there's some wires there, but that's okay. Yeah, and then, okay. I think I'll go for those screws first. Oh, screwdriver. What else we got? Well, I can't use the leather man. That's not going to fit. That's not going to fit. Have better screwdriver options. It is always key. It is always key. Thank you. Maybe I should bring that screwdriver back, because then you guys won't have to scream at me. What are you doing, Dave? That's an awful choice. Why would you pick that part? That's a terrible screw. I'd agree with you. I do agree with you. But there's also a part where you just, if you proceed carefully enough, should be able to make your way, especially if you know what you're going to do with those parts. To me, I might also end up replacing a lot of screws. I don't know. We'll see. And just, there we go. Here we go. The tuning capacitor is starting to free up, so I'm going to hold on to that now. Okay. And there. And boom. There. And there we go. Got the whole thing. I don't want this to bend or have any issues, so I'm going to leave these off. Just put those in there. I don't want this to break either, so I will take this off. It's just a little set screw. Off that comes. And there's the main tuning capacitor. So we can actually take a close look at this. There's that kind of bread slicing. Along the edges, you see these sliced up ones here and here. And I also see that they're slightly bent, closer in some areas and further away in others. So a variable capacitor, and then also has a kind of particular, what do you call it, kind of snail shell shape a little bit, just kind of flat, but it's definitely a different radius in here than it is out there. This is all the remarkable entailments of the geometry that you have to have for capacitance. So capacitor can be very, very simple. You just have two layers of conductor separated by something that doesn't conduct. Charge will accumulate on one side versus another, and in that way it holds energy. And where it's important for our circuit here is that proportionate holds energy, that capacitance is the property. If it's balanced in a certain way with the coils, and we happen to have 4 coils for the 4 different bands, you can rotate it to change that property, which essentially tunes the combined inductance, the coil, and capacitance, the variable capacitor here. It looks, so what they do with these edge plates here and here is that it allows them to tweak the amount it changes for each bit of rotation, just ever so slightly. As these are made, they're fairly okay, and they're how much they change per little bit of turn, but it may not, for a certain application, be the right amount. Or if you have a pre-printed dial, I don't know that they actually went to this effort, but if you had a pre-printed dial like this and you put it in a certain position, and that tuning capacitor only mounts in such a way, I do hope that when I tune it, I get pretty much resonant, the radio operating at 2 megahertz here and about 4 megahertz here. I don't want my capacitor that's like, oh, actually 2's here. So I'm not going to make special silk screens to cover all that. Instead of making silk screens that cover the capacitors, you change the capacitor to match the profile that's printed on the dial, and you can do that by just bending it. So some areas it's a little closer. That means in that area that the capacitance change will be, I'm going to guess, greater. Yeah, I hope so. And in other areas it's further away, which means a little less capacitance in that area, and that changes it. And that way you can tweak them. These capacitors also usually come in this form where you have one section here that's a bit smaller than the other. These are reused from a very common type of radio receiver made in the 40s, 50s, 60s, maybe 70s, I don't know, called the All-American 5, and 5 meaning the number of tubes it had, and it was a architecture called a super heterodyne, and in that there are multiple circuits. There's one section called the oscillator. That would get one section dedicated to it, another section that's meant for the the actual tuning to the operating frequency, the thing you're trying to listen to, and that would be the other section. And then lastly, just some other things. There's these little bits of shiny, clear material here on these screws. These are some further adjustments you can add called trimmer capacitors. So the way they work is, let's see if I can undo it. There's a metal plate here that's from this capacitor. And in fact, this trimmer capacitors and I believe parallel with this. And then there's that thin, clear material here. That's actually a mineral called mica. And mica is this silicate that flakes in this really thin, almost transparent sheet. And honestly, here it's so thin, it is transparent. And it's very highly electrically insulating. In a capacitor, you have those two metal plates, and an insulator, there's an insulator. And then you have another plate here connecting to the frame with a screw. So as you turn the screw, this forces the plates to come closer and closer together, which, if you look at the equations about how a capacitor works, means that the capacitance increases and increases. So then that way you can tweak the total capacitance this shows. You can tweak how much it changes per unit change by bending out those little plates. And that way you can tune, so to speak, the capacitor to meet your needs. There we go. All right, time's wasting. We got to get this out of the chassis. We get those. Wow, those are long screws. There we go. This is part of the antenna circuit that went to the binding post in the back. Here's our 3 screws for mounting it. Those are all accounted for in the part sheet. Now those long screws are going to be a bit hard to find, so I'm going to really try to keep those. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 screws to do, and a few of those are kind of big. Go. So I'm going to follow mostly what I'd shown before. Just loosen a bit. We're going to drop a lot of, apologies, we're going to drop a lot of nuts onto the bench. That's okay. Just keep them going. I've never done a radio like this where I literally just drop all the circuits onto the chassis. I've done radios where the boards come out. That's one type. That's fine. It's really nice and easy. You just take the board out, whether it's you know, soldered in place with connection wires, or it's socketed or something like that. But being able to just drop it like this, you don't see unless you do a kit. Okay. Let me go like here. Okay. So if you're thrilled by this, you're like me. So this part is mostly, this is the most fun sort of destruction you can do. You don't often, like I said, work at this. You kind of work with what you have. And if I was polishing this chassis, I would try to do it with all the parts in place. You can't really drop everything out like you can in some other designs like this. Kind of go at it with as much detail as you think is appropriate. I've done things where I just want it was like test equipment, I should say. And you could baby test equipment all you want. That's all those are coming off. But I mostly just wanted to do the job. So I won't do a bad job, but I'm not going to go in and polish the screw heads and things like that. Right. You, not you. get to, I already had a nice wooden case made for this radio. I made a walnut. It'll show up later in the streams. And that's because it's such a fun kind of radio to play with. And you're going to be staring at it, especially if you're trying to operate all those controls. Might as well put it in a nice case. And plus I can do something like this. I could literally make it as nice as I want. And actually, you can sort of see. This was trapped underneath the front panel for all those years. And it's still kind of nice and shiny. You get a side that's been exposed to the weather, the elements. You see this kind of yellowish tinge. These chassis are plated in cadmium, which means I'm not going to go eat a sandwich after this session here. And cadmium, as it oxidizes, kind of like with actually it operates very much like galvanization. It acts to take the corrosion that would always hit was underneath a steel chassis. But as it oxidizes, it leaves this yellow film, which is a cadmium dust and should not be breathed. I wouldn't lick a chassis. What's actually more likely is that you work on something and then you grab a sandwich and you eat the dust. Not good. Not good. Don't do. Okay. And out it goes. There are not very many screws left now. 2, 1. Oh boy, I'm excited. No, I really am excited. And that did not sound very excited at all. But I am. I'm about to do something I haven't done before, and that always makes it fun. Okay. I think that gets it. Now, I am... There's most of the screws. So, here we go. There's the screws. Now, thankfully, all this other stuff is mostly common. Okay, so the flathead screws, maybe a little less common now. These interior toothed washers here, I have boxes of these things from doing previous jobs. What is a little more rare sometimes are these nuts. If you get a nut today, it's a little washer. If you get a nut today, they're likely not going to be as thin or as narrow as these original nuts. Sometimes, yes. And if you order from a particular set of vendors or having certain characteristics, but if you go to that hardware bin at the hardware store, the things you're going to get are going to be bigger, and often you get into trouble. I can see where that would happen here. Those nuts fit into these little grooves on the socket, which actually we'll see. But if you put in a bigger nut, it's not going to go. It's going to get jammed up. It's not going to fit right. And that's where you're going to end up seeing things like the screw heads don't really hold well, and all this garbage. Okay. One screw left. Okay. One screw left. We get it. Okay. That's out. That's out. That's out. There's the controls. There's that nut and washer. And there should be nothing holding all this stuff in except just all of this. Ooh, ooh. Now, I gotta still be very careful. These controls have to come out. These coils, I don't want to fracture the terminals from the formers. There's like a little bit of wire hanging out here. Okay, there we go. Whoa, there. You want to talk about free? There's free. Boom. Okay, that was loud. Sorry about that. And now we have something I've never seen before. I'm going to put this against a backdrop. Look at that. That's most of the radio right there, just all floating in space. And look, it's a lot of points being used to mount here and here and here. There's also a number that's used for grounding to the chassis. Yes, there's one electrical connection here. A lot of grounding, actually. But there it is. That's the radio. There's a pile of wires, components, and then parts. And then from there, it came off a bare chassis. There we go. You can even see there's where that transformer was right here. A nice low sheen to it. And then here's the oxidized surface. This was protected. This saw it. You also see there's some rust spots all the way through. All right, chassis out. Home stretch. We're going to chop this down. Do it. I'm not going to keep the wire. What I will do is keep some examples of the wire, because let's see, the parts list, which is right here, those parts are given as just yellow wire, green wire, just their colors. Oh, there is some mention. There's a 20 gauge solid bare tinned wire, and then a length of 15 feet of 15 inches of solder off there. So I'm going to keep some examples of the wire so I can go shopping, which will be the next stream, for some replacements. I'm going to guess that a lot of the stuff is solid. It kind of feels that way. There might be some stranded here too. I'm going to remove especially all the important fragile parts, the individual band coils here, 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 and here, the controls, and I'm going to probably remove and keep the terminal strips. Okay. And snip, snip, snip. We go. Oh, and this is that polyvericon I was working with. And I have a number of these to boot, so I don't have to be too careful. No sense in wasting it. Now we get closer. You remember how that how that capacitor was structured. This one here, it's been replaced. It also has metal plates. You can see that easily. Probably not. It has a very similar structure, but instead of the kind of air gap between plates, it uses a plastic between. It actually allows you to have a high degree of capacitance between the plates. If you put materials in, it multiplies the capacitance you can get, but it has some other effects. So this is just a ceramic capacitor on a terminal lug here and a lug here. I'm not going to necessarily butcher it, but I don't have to necessarily keep it either. Boom. Boom. Save those. Keep that in my probably to be. So these are common. I'm going to get replacements to go into the radio. We also now have these parts out. We can put their nuts back. It has these very large internal tooth washer used to help keep them from rotating in the panel after it's been really cinched down by the nut. That's our old regen control. It's a potentiometer. This here is a potentiometer, but it also has a switch on the back. Nice click too. Okay. And then finally, that's that band switch. Yeah, might be the first. Snip, snip, snip. Here we go. Let's reach for the ones that are projecting from the top. There. 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 And that comes off of there. There's my wire. And away we go. So this is that AC line cord. One part goes to this tube socket. That's where that 35W4 is, which is a rectifier. That's part of a component you need to turn AC into DC. We're just gonna completely replace that. That's trash. I didn't hit the can. Okay. Fine. Now, part of that circuit includes electrolytic capacitors. This radio, because I wanted to get it working for this video, does not have the original, but it's what's called a multi-section electrolytic capacitor. That's inside. It has 3 in 1. So it's more convenient to slip into a radio and just route the wires to different locations. You can mount it on the side of the chassis. I think in this one, that would have mounted here and run with 3 red wires to different points on the terminal strip here. Okay. There. This is a replacement that I put in. It's part of the audio circuit. Probably put in a better one next time. Okay. Let's see. These are common, so I'm not too concerned about preserving them. So I'm not going to go through how we're going to recover some of the components, because as you get them, they still have chunks of wire hanging off them like that. Instead, I'm going to do one example part, and in the next stream, all the parts will be cleaned up and ready for us to go through and shop for replacements. Okay. Now, I've been pretty tough. Yeah. Yeah, that's interesting. Hey, thanks, Mike. Let me take a look. Oh, yeah, you can see it. Okay, so what we see here. Oh, that's perfect. You can see that. That's great. So this was built. Someone's handling it, and then it gets trapped under the front panel for a long, long time. You can actually see the remaining fingerprints of the previous owner all through here. Like, that's neat. Because at that point it has extra salts, and the moisture from the air acts to corrode them selectively wherever there's these ridges and grooves. Boy, you can literally take a fingerprint. Now, I actually do know who built this, so it's not too much of a mystery who that was. But this is kind of neat. I like the part when people cleanly and with you know, a little note either inscribed in the back or inside the chassis who they were, what their name was, or if they're ham radio call sign, and say you know, the date they built it. I think all the radios I really have liked enough to do up a like this. They've been inscribed with something, and sadly, one of the reasons I end up with or I'm able to buy the radios is because someone had passed away, and it was being sold at an estate or auction or something like that. But it's kind of cool to think about the continuity of these objects that we admired them for what they do, and especially if you're the first person who got it, it's like you admired the whole thing. You wanted to buy it and make it, and then it kind of moves from hand to hand. I feel like radios. There's a number of things that are like it too. Vintage records, maybe too, that have these really extended lives to them, just going from place to place. And it's fascinating to think about all the hands that they go through over time. So here's which coil is this? I'm gonna guess the low shortwave coil, probably. Oh, B coil. Yeah. Okay. So right here, B coil. So this is used for the low shortwave band. Now I'm gonna be really careful here, and that frees that lug up. That's not too bad. I can get more. But that's coil mostly free. It still has all those little chunks of wires. I'm not going to show it on these. I do want to put more thought and care. I'll show on the other parts how those can get cleaned up. It'd be really nice if you have a really good vacuum desoldering station where you can come in with a tip, and the tip has a hole in it connected to a vacuum system. You go in, heat the joint, click the vacuum, and it'll suck the solder right out into a chamber. It's very clean. You don't have to mess about with the wick. The wick is cheap, though. Well, I should say it's relatively cheap. It's not actually that cheap. It's really cheaper than a machine, though. Would love to have one on the bench. Would love to have one. Love it at work. And I don't do work project. Actually, I don't do home projects at work. Works for work. Build a better workbench at home. Right. That's free. Thank you. Okay, that's. I think that the color code. I bet the red carries the what's called a B+ voltage, which is the main power bus for operating the circuits. There's in tube circuits. There are always at least two supplies. One is called the filament voltage. If you recall when I was talking about it, that the essentially vacuum tubes are modified light bulbs, and inside they have a small filament, and it's actual electrons, like real live electrons. It's not real life and all stuff, but it's something about them flying in space that you can actually see. What space they're flying in. That they do their magic. But to get that, you have to heat a metal up pretty hot, like a filament, and for that you need to have a separate filament supply, and that tends to be lower voltage. You can sort of guess that from the rating numbers on the nomenclature numbers, like a 12AX7. It takes 12.6. I just know this is 12 volts, 12.6 volts actually, to operate that filament, and it takes a lot of current. It's a little light bulb filament. Those took a lot of power. So that's one. That's just to make them be electronic and not just an inert bottle of glass and junk. The other supply is commonly called the B+, and that comes from some old terminology when everything had to be run on batteries. The B+ voltage is a high voltage because what it takes to actually move these electrons around and to do the electronic work you want is it's a high voltage. Maybe you recall from your high school physics class, at least we had the videotape version, that they had these things called cathode ray tubes, and what it took for the cathode ray tube to glow on one side was a filament that would let off the electrons, and then a high voltage which would cause the electrons to move across, accelerate across actually, over the electric field that this high voltage produces between the components inside. And this would accelerate the electrons so that they would hit the glass covered in a white phosphor and then glow green. So wait, what do we have here? Seed coil, that's free. I think I got them all. Yeah. Cool. Did I get them all? No. One more. It's visually blinded. It's the A coil. Boy, this is the important coil. If this thing cannot get broadcast band, then why bother? All right, here and there. I wonder if black is return or ground. I bet it is. Okay, one more, and that's that. I bet to be B+, and then we're free. There's the coil. So from here, really what's still important are these controls. These, particularly something like this. It's kind of an oddball. I've not seen a rotary switch that looks like that. This is one of those things, if it breaks, you're kind of in a tough spot because the radio is designed with, especially with something that has that many wires coming off of it. Radio is designed around being that layout, and you're in a very difficult position if this got really broken where you couldn't fix it. You could replace it with something. It would just be kind of challenging. Try not to get there. Band switch breaking is, that's what these are. They're usually the most complex, mechanically complex part in many inexpensive radios. They're also typically the most fragile to being really worked on. This is just a thin sheet of phenolic. This is kind of composite material, and it's really prone to cracking if you wrenched on one of these lugs too much. And then you're going to have a bad time. And away we go. So this is the teardown. We did the operation. You know the radio pretty much works. The next stream, I'll show a bit about how I clean these parts up, but it'll be mostly shopping. We'll have some video segments where I go out and do some literal shopping. Sometimes if you can get at a place, and I have a great little electronic shop up the street from us, it makes it so much easier if you can get out there and it's like, okay, well, I got this sort of wire, you know, and I want to, this is all solid core, and they have piles and piles of spools and of wire in the back and things like that. That's the best place, because if you go to DigiKey and it's like, okay, I want this much, I want wire like this, but I don't really need very much. They're not typically going to sell a short length. I mean, in some instances they do, but and then you're going to be in for, 50 feet, 100 feet of stuff like that. So as much as I've ever learned in restoring radios, know where to get stuff that you don't have to pay an arm and a leg to go do it. Often that was Hamfest. I could go to a Hamfest and go dig around and find wires like this. My local electronic shop is nice too. And then when it comes to it, like semiconductors, common parts, there's a number of great options for current electronics as well as vintage. I like, for common stuff, like DigiKey and Mauser, and then for the vintage stuff, there's a great vendor up in Canada, Just Radios, that makes kits of parts, all that right kind of capacitors to replace the old paper and electrolytics. And I like, okay, that's mostly cleaned up enough, at least enough to clean. Yeah. This will be easy. It's just a pot and just 3 leads. Those are the 3 leads, the both ends, and then the wiper, which typically is in the middle. And there. And I want to really make sure it doesn't wrench. There we go. Here's the pot. Yep. They really went to some detail. Like each of these parts, you can see it. It's stamped with their part number, 11-27. There's no, it's not silk screened on. This is just stamped like that. Very nice. Very helpful. And then we have the volume pot. You can see the two sections. Here's the volume pot section here, and back here is that switch. And there's two terminals for clicking the AC power on and off. See, works great. Okay. The pot's free. Okay. And wow, there's a lot of stuff on that. That must have been. Home stretch. So the tube sockets show the detail. So these are meant to mount from underneath the this black plastic. This really kind of phenolic material. It's meant to tolerate the high temperature of being essentially under a light bulb. Let's see if I can. Yeah. There we go. Like so. Right. Yeah. There we go. Each of those connectors are available off those lugs there. And I've been warned, these are fragile and just factor in having to replace them. You don't typically. Some of the better, higher quality components, particularly in old vintage commercial, test equipment, military stuff especially, it was built like a tank. Sometimes you'd find that these are actually not. This plastic's fine. I mean, it'll operate at a very high temperature. It's not the weak part of these sockets. It's the terminals. But sometimes, and it depends on the application. They don't use the phenolic. They use ceramic, porcelain. I think it's ceramic. Okay. Put that off to the side. We can almost get that free if we cut this wire here. This is, I'm watching this as you guys are, and I'm looking at it, and it's like this is the complete opposite of what you do when you're restoring a radio. You don't take it. Look at this. This is maybe the worst thing you could possibly do. This is the pinnacle golden screwdriver. They're like, oh yeah. I'm gonna go in and replace every part, right down to nuts and screws. It's crazy. You otherwise wouldn't do it. And honestly, I didn't have to do it, but I did for you guys. I did it for me too, but I did it for you guys because I want to see what that is like. So I've just liberated my multi-section capacitor right there. So each capacitor has two leads. In electrolytic, there is a polarization, one positive, one negative. On this capacitor, all of the positive leads are done in the red, and that's what's coming off of each side here. This is a radial type capacitor. And all of the grounds are all tied together in the middle. Then it's insulated with some Kapton tape around the sides and top and some hot glue here. And that forms a really compact replacement. It's not pretty, can certainly do better, but it is electrically functional. There shouldn't be any problems there. And it worked well enough. I mean, I'm not entirely know whether their radio is supposed to hum that much. I don't think so. Not like when the volume's turned down low. But we're gonna find out how well this can work when we follow the instructions and put it all back together. Okay, this we might be able to save. There's a lot of extra lead here too. So there's that power resistor. 200 ohms, 200 ohms, 10%, 10 watts, and that has that nichrome wire running in it. Much like you have in a toaster. I think that's actually nichrome ribbon in a toaster. You can see it. I mean, that thing, that kind of flat shape that glows orange, that's the resistive element in a toaster. And they look flat, and they're wound, actually, they're wound around something that looks kind of grayish silver. That's, I'm pretty sure, a mica-based material. So all the same stuff we saw on like the electrolyte capacitor and other things, you'll find in other appliances if you just take a look. I wouldn't stick a fork in there, but you'll definitely see it. In fact, if you get fancy, some of those special like toasters that put the faces and shapes on bread, you know, you should be able to see a different pattern. I don't know if that's done with the tape though. Okay, we're almost ready. Oh my gosh! Boom. Okay, there's that. There's that. Oh boy. Good. And good. Let's take off that last little capacitor. There. There's a socket. There's a socket. And this socket. Okay, so this one is... This was the one that was used for the... which should be the 12AT7. That was a 12AX7. So there's two parts here that are kind of critical to it regenerating. And that's this capacitor here and this resistor here, and I think that was just kind of really up and tall and like that. Don't think that was what they called for in the instructions. I don't know whether that caused any of the issues I may have seen, but it's not great. Probably not bad, but it's not great. There we go. That's another socket. Let me take out those wires. So we're just going to do one socket and then call it for the night. So we're almost done here. I'm going to pull in all the parts for a group shot, show you that, and then how we might clean some of these parts. So yeah, so we're going to do the stream where we shop, then we'll have to wait to get the parts in. But once we're there, we can talk about putting it back together. Now, putting it back together is going to take longer than it took to take it apart, even if I do my best to not try to explain things. So what we're going to likely do instead is a released video rather than a stream on that day, just zooming through the assembly process. Because really, it's going to follow the manual. So this part I want to keep. This is what's called an RF choke. So essentially an inductor wound over a little resistor. Here's the wire windings of an inductor, a coil in other terms. And then there's a body underneath. That body sometimes is just a body. There may not be something special. And sometimes there's a resistor in there, because the combination of the inductor and resistor gives an electrical characteristic that's desired. It's meant to block RF signals from getting back into typically a power supply circuit. So that's why they call it an RF choke. It chokes the RF from proceeding further up a circuit than it should. That's special. Okay. What else? I think that's just about it. Just a few more components. I really just want the terminal strips. And there we go. What do we got? So, take all the, there's our resistors. Here's our wires. Okay. Resistors, capacitors. Here, here. Yeah, plenty of these. This radio had no paper capacitors. I don't know if the design maybe didn't even ever have them. But certainly, in this radio, there's none. All there was electrical capacitors. I could just go in there fairly quickly, throw together this quick replacement and get the radio well enough to work. Okay. All right, here's my electrolytics. My stuff. Oh, I can't separate you. You guys have to stay together. It's just too heartbreaking. I can't do it. There's a power resistor. There's some coils. Here. Here. All right, the headphones. Here we go. Switches. Controls. Let's see. There. Okay, let me move that down, move that. There's all the parts. Okay. Oh, let me separate that. There's our sockets. There. There's our terminal strips. There. You add to that pile of parts. And it's back to being a kit. Add our chassis and our front panel, which I've already was trying to protect there. So what I would do, and I'm going to do this off camera, is to go through the parts list again, take all the important pieces that I want to preserve, the terminal strips, perhaps the sockets, definitely our control parts there, and especially these coils. Those are important and hard, very hard to replace. It can be. It just becomes the whole product. And then from there, I can build the list of things that have to be replaced. All right. So now we've done this, but we still have a bunch of solder in all that. We have a bunch of wire in there. We especially have that here. That's going to be a night's project. So we'll pick something simple, something like this. All right, I can't do it. I can't just push it off edge. Okay. This I can. So what I like to do, and this is not necessarily the way to do it, but it's one I've always used, is often with these there's a lot of blobbed solder in there. I will take a pair of either tweezers or something else. Let's do this. Apologies. And there we go. Nice neutral background. It's not typically the way you want to do this, but for you, I'm just going to show it. I like to have nice temperature resistant the silicone pad, something underneath, not the base mat that I have on here, because what we're going to do is we're going to want to remove a lot of the extra solder from these parts, and we can just use that using a bit of heat and a little bit of shock. So heat the part up, look for the magic, that kind of look where it's all molten, and then And there it is. There's the bulk of the solder coming off the part. And then what's left is not too bad. Sometimes you can actually go in with, mind it's still hot, you can go in with the angle cutters, because if this wire was put in correctly, it was wrapped around. So then it forms a loop. We want to open and cut that loop. Open right there. So now it's just a U, and I can come back in with the soldering iron and get it back out. This one does a little finesse, and then you've got most of the work done. Didn't take very much time at all. You just get that. I learned that from an old timer, or at least in the ham radio lingo we call it Nelmer. You just kind of strike it at the end of the bench. So that's not bad. It's still hot, but it says it's pretty much clean right there. And let me just quickly do the other, and actually this piece will be done. I might clean up the extra rosin flux that's left behind with some alcohol, but other than that, it's ready to do its job again. All right. Okay. Okay. And that's, be careful. This looks like it was both a stranded and braided wire that went through. And it mostly cleans it up. That mostly cleans it up. Very good. A little bit of wire there. I'll get that off camera. So now we get the mat gets loaded with this. It doesn't melt onto, especially if you have an inexpensive pad underneath. But then that part is pretty much ready to use again. Okay, so that's the enkitting of this vintage regenerative radio. Over the next 3 either streams of videos, we'll be working on turning all of this into clean, ready-to-use parts, and then going back in time and building it like we were there back in, I don't know, 1964, 65 maybe. And we'll see how well, if it works again, and how well it works when it's all put together with new modern components and following the assembly to a T. So what I like to do at the end is, first, thanks to everyone checking in and watching. This has been lovely to do this project with you tonight. But what I also like to show is just some other things that we have that are kind of neat, that are cooking, that are passing by this way, that you might also find interesting. So at the same place that I got this radio, the fellow who owned all this stuff was an engineer who was doing all sorts of things, and he picked up things just to experiment with. One of them is this thing, the Bell Solar Energy Experiment Kit, the Bell System Science Experiment number 2, and it's in its original box. Look at that, and it warns about some stuff going on. It's from 1962. It says right there, and should help. Apologies, thank you. It warns there's some chemicals inside. We got boric acid, we have sodium hypophosphite, and calcium fluoride. An experiment in physics and chemistry converting solar energy to electrical energy. What's inside? This literally came out of the same storage cabinet where all the radio stuff came from. I just kind of got it as part of it. So first we have a book made available by your telephone company. I love that. Wow. Got this wonderful book. Oh, there's the author. Where is he? You're here. I saw you. Dr. Darrell M. Chapin wrote this book. Now, I've already taken a little look, so it is a riot what is in this thing. So now hopefully I'm still streaming. Apologies if there's an interruption, but okay, we're going to proceed. Individually, each one of these tubes has some chemical. Calcium fluoride. This is essentially a chemistry set. Oh, what is that? I did not know that. Oh, a heater coil? Oh boy, look at this. So this goes into a socket, and this is a high temperature ceramic. There's this nichrome type wire. So that's actually, this is a heater coil. Why would you need a heater coil? What are these kids up to? I don't know. Yeah, so I'm gonna guess what this kit is about is you are charged with understanding solar materials, and you're going to literally dope your own silicon. Oh, good. Yeah, actually, I'm most certain that is. Here it is. You're going to dope your own silicon wafers that are in this container with all these different chemicals. Yeah, that's what it is. So, what chemical? So it says a lot of carborundum, it's ammonium chloride. Nickel chloride? Yeah, there we go. Nickel chloride. And let's see, we have high temperature paddle, wire, solder, force. Oh, crap. I think I know what that's underneath. I gotta be careful. Okay. Polishing plate. Oh my gosh. So, I think I remember reading about this. This box asks whomever's doing this to dope their own silicon. And you dope the silicon by coating it in different materials and then heating it at a high temperature. So all through these experiments, yeah, there it is. You see here, example. You paint the silicon slab with the boric acid water mixture right here. That's your doping. And then you put the silicon into a furnace that you use the heater coil for, and some high temperature plates and this stuff. Oh, it's called a glow coil. This stuff and this stuff. Okay. This, Jesus. This and this, plus these high temperature bricks, are a furnace. The glow coil, or the heater coil, acts as your tube furnace, and you place your sample inside the tube furnace. So with that material, it bakes and then diffuses into the silicon, forming either a N-type material or a P-type material. What I'm concerned about is what this is made out of, and I have a guess. Now, oh no, what are you made out of? Oh yes, that is true. Here it is. Oh no. And if you can see that, it's asbestos. So this kit has 2 sheets of asbestos in the back. It's got a bunch of fun stuff there, but okay, that just got a bit more dangerous. Okay, it's been more than 3 hours. I really do thank you all for joining me tonight. And if you've enjoyed this, let me know what I could do to make it interesting, better. One thing I do know is I do want to make them shorter, keep them more focused. I might cut more of the instructional material, just get to the soldering, I think, or get to the actual playing around with the radio, than talking about how it works. Because really, ultimately, it's using the stuff that's the most fun. So I again thank you all for the company, and the next stream will be next Sunday at 7:05 p.m. and you can join me then. That'll be a combo of shopping for electronic components, as well as some of the other video having to do with going to the electronic shop and the like. I'll put it out. Are there any questions on chat or on the direct text line? And while I'm doing this, I'm also trying to get back. My machine shut down. So apologies here. So thank you for all the thanks. That really, I do appreciate it. And Mike, thank you again too. It's I'm really getting a hang of this. This is really my really second stream, so I do what I can to make it better and better. I hope you all liked it, and I think with that, I'm just going to awkwardly try to get back to the stream shutdown screen, and wish you all a good night.